All right, folks, we are talking about systems of equations today, and we did this a little bit Wednesday. Y'all had some word problems. We're going to grade that at the end of the lesson. And I really need your full attention because this is another favorite topic on the end of course exam. There's lots of ways to solve systems, word problems with systems. They love those. The methods we're going to talk about today. Well, first of all, why is this a system? Because there's two equations. A systems of equations just means there's more than one. Most of the time we focus on lines, like two or more equations of lines. It could be two parabolas, it could be a line and a parabola, any two types of functions. And we're trying to find their solution to their system. On the top equation, y equals 3x, guess how many solutions there are to that? 76 solutions. That's pretty specific. There are billions upon trillions of solutions to that equation all by itself. Okay, there's millions. Whatever value I pick for x, I triple it, that's my y. And I could do that 100,000 million times. Guess how many solutions there are to x plus y equals 12? Again, 72. No, how many? Millions upon billions upon trillions. However, folks, listen, and this is important. I need y'all paying attention. How many solutions are to their system when we put them together? How many answers are there going to be? One. What we are looking for here is the one point where these two functions do what? Where they intersect. Okay, so separately, the equations have millions of solutions, but put them together as a system, and we're looking for the one place where they intersect. There's one point that works on y equals 3x, and that same point also works on x plus y equals 12. How many times will two lines intersect? Just once, if they intersect at all. So just let me give you some other scenarios. When you're talking about a system of linear equations, ladies, most of the time there's going to be one solution, the one solution where they intersect. But that's not the only possibility. Most of the time, that's what we're dealing with. But every once in a while, you're going to come across a solution, well, where there is no solution. Can you imagine how in the world that would happen? Parallel lines. Okay, so here are our possibilities. We could have one solution, and we're talking about linear systems. Linear systems, if they're going to intersect, can only intersect once. So that's possible to have one solution if they intersect. It's also possible to have no solutions, and when would that happen? If they are parallel, if they have the same slope, then they will never intersect and they will never have a solution to their system, and that does happen as well. And there is one third case, and that involves, do you see how all those different forms of lines I have over here on the board? We got standard form, point slope form, slope intercept form. They could give you two lines in different forms that look like different lines, but then when you try to graph them, they end up being the exact same line. Guess what happens then? How many solutions would they share? Yeah. You could also have infinite solutions. That means everything's exactly the same because they are the same line. But it's easy to make lines look different because there's so many different forms of lines. Now, what's the case that we're going to mainly deal with? The one solution. Usually you're going to have two lines that intersect, and we're going to find the one solution. Now, I used to teach everything about lines before I ever let a student touch a calculator. And my philosophy has changed. I would feel very guilty, though, if I didn't show you the mathematical way to do this. So we're going to do a couple the mathematical way. But I strongly suggest that you use the calculator to do this. Doesn't mean there's still room for mistakes. Doesn't mean there's not work you have to do even to make the calculator give you the answer. But I think it's going to make your life easier. Let's real quickly though, just so I don't feel guilty for the rest of my life when you guys are seniors in high school and I never showed you this. Let me show you what's called the substitution way. And it's kind of what you did for homework on page 340, that homework I assigned you on Wednesday. Okay. This is substitution ready right now. And the reason why it's substitution ready is because one of the equations is solved completely for y. You need at least one equation to have a y or even an x all by itself. And if it does, then you're ready for substitution. Look at that top equation. What does y equal? Do you see? Y equals 3x. Come back. That means y and 3x are interchangeable. They are exactly the same thing. They equal each other. Now, you have to now look at the other equation. Do you see a y in the other equation? Yeah, do you see this y right here? Guess what I can replace it with? 3x. Okay, the reason why I need to do that, folks, is because, again, millions of solutions to each one of these equations separately. We need an equation that only has one letter in it, or we can't solve it. So we're going to create another equation that only has x's or only has y's, whatever it's set up to do. So look at this y right here. I'm going to take it out, and what can I replace it with? 3x. Because y and 3x are exactly the same thing. Right, Mia? So instead of x plus y equals 12, what's it going to say now? X plus 3x equals 12. Now I have an equation that I can actually solve because it only has one letter in it. If x plus 3x equals 12, then that would be 4x equals 12. And what does x equal? 3. And I'm still not done. Because linear functions, if they are going to intersect at a point. Not just a number, a point. What number did I find? I found the x number. Now I have to find the y number. Now, to find the y number, go back to either of the original equations you started with, and I'm going to take the x out and put in a 3. So instead of y equals 3 times x, it's going to be y equals 3 times 3. So what does y equal? 9. I could have done the same thing right here. Instead of x plus y equals 12, I could have done 3 plus y equals 12. Subtract 3 from both sides, and guess what y equals? 9. Now, how do I write the answer? No, these are not. You could write it like two separate answers, x equals 3, y equals 9, but those two numbers go together as a point. I would write it like this. That's the point where these two lines do what? That's where they intersect. Now, let's talk about the calculator way. Remember, 3, 9 is what we got, right? Here's the calculator way. If you know equations, where do you go? You go to y equals. But the problem is, they're not always set up like y equals. We got lucky on the top one. Y equals 3x. I can absolutely put that in. Y equals 3x. I cannot put in the bottom one yet. What do I have to do to the bottom one? I got to move x. And this is a skill you have to be very good at anyway. So why not? Let's just practice it and solve this with our calculator. Y equals what? Negative x plus 12. So now I'm going to put that one in. Y equals negative x plus 12. Now, always look at it, please, first, because I'm telling you, if the calculator can't see where they're intersecting, and it can barely see it, it will not tell you the answer. So sometimes, what are you going to have to do? Zoom out. I don't need to zoom out because I can see where they're crossing. Now, how do I get the calculator to tell me the answer? Second function, calculate intersection, first curve, second curve, guess. And sure enough, look right there, 3, 9, right? Are y'all with me? Because this is a very important skill. They love systems of equations on the end of course exam. All right, look at this one, number 2. Y equals 3x plus 2. X equals 25 minus 2y. We have some choices here. Both of these are substitution ready. To be substitution ready, ladies, please, one of the equations either has to have y all by itself or x all by itself. The top one is solved for y. The bottom one is solved for x. I have a choice. I absolutely have a choice. Since y and 3x plus 2 are the same thing, what could I put in place of this y? 3x plus 2. Or I could do something completely different. Since x and 25 minus 2y are the exact same thing, what could I put in place of this x? 25 minus 2y. It just depends on which one you want to do. What do y'all want to do? You want to substitute the x into the top? Okay, now here's another catch too. If I'm going to choose to substitute this into the other equation, what's happening to the y in my bottom equation? It's getting multiplied by -2. That means whatever I put in its place has to be put in parentheses. If I'm going to take this y equals 3x plus 2, so if I'm going to take this y out and put a 3x plus 2 in its place, what do I have to do? I have to do parentheses. Have to. Okay, so solve that now that we have now we have equations with x's, because we really took this y out and put a 3x plus 2 in its place. Solve that for x, please. I'll race you on your mark, get set, go. And show me with your hands what you got for x. Good. I got a whole number. I got positive. Okay, so this is what I did. Instead of x equals 25 minus 2 times y, I took this y out and put 3x plus 2. So then it became x equals 25, and I had to distribute here, minus 6x minus 4. Then I added 6x to be with the x on the other side. I got 7x. And then 25 minus 4 is 21, and 21 divided by 7 is 3. Am I done yet? No. If x is 3, and I'm going to go back and rewrite this like it was, I still have to find y. What do I do now? Yeah, I could do it into either of my original equations. To me, the top one looks easier. Wherever I see this x, what can I put? A 3, and then I'm going to be able to find y. What's 3 times 3? Plus 2 more? 11. So y equals 11. So how would I write my answer? 3, 11. Now, how would I suggest? I want you to I want you to understand how this works. I want you to understand substitution. But now that we already are using our calculators, the top one's ready to enter y equals 3x plus 2. The bottom one takes a little bit of work. Some kids are having a lot of trouble dividing by negatives. That messes them up. Guess what I could do on the bottom equation if I didn't want y to be negative? I could move the y's to the other side. Do you see what I'm saying? I could move this over here, and then I would have 2y plus x equals 25. Now what? Move the x over, and I would have 2y equals negative x plus 25. And here's another place where kids have trouble. I got to divide everything by 2. You know how you can do that? If you're having trouble, you can individually divide both of these by 2. Or you know what else you could do? Put that whole thing in parentheses and then divide by 2. And that'll make sure that everything gets divided by 2 if you put parentheses. So if dividing by 2 gives you trouble, then do it that way. The calculator can handle that. All right, so let's go to y equals. We already had one ready to go. Y equals 3x plus 2. Oops. Y equals 3x plus 2. The bottom one, now you got to be careful. If you don't want to individually divide everything by 2, then you have got to put parentheses. Negative x plus 25 in parentheses, whole thing divided by 2. Make sure we can see it in the screen. And you know what? I can't. Do you see how I can't see it? Guess what I have to do? I have to zoom out. Zoom out, enter. As soon as you can see it, you're fine to do calculate intersection. Second function, calculate intersection, first curve, second curve, guess. And there we go, 311. Now, let's say you don't mind dividing individually. Another way you could have written this was y equals negative x divided by 2 plus 25 divided by 2. Each one could individually be divided by 2 or the whole thing in parentheses. All right, look at this one, number 3. 2x plus 3y equals 9. Is that one substitution ready? No. X equals 4 minus y. Is that one substitution ready? Yes, because wherever you see an x, what can you put in its place? 4 minus y. Now be careful. In the top equation, what's happening to x? It's being doubled. So you've got to double whatever you put in its place. I tell you what, you can do this by hand or you can do it by calculator. You choose. All right, you go. I'm going to just sit here and be quiet while you work. Both of them take some work. Because neither one of these is calculator ready. Neither one of these is in slope-intercept form. So you've either got to do the work to convert or you've got to do the work to manually substitute one equation into the other. And if it were me on the end of course exam, folks, I would do it both ways. Triple, double check yourself. Here's another thing. You're going to have answer choices. You could plug in all the answer choices until you find the one point that works on both of the lines. For you calculator people, look at the bottom equation. You know what's a really easy way to get y by itself and not have to deal with dividing by negatives? I would move the negative y to the other side, and I would move the positive x to the side that's got the 4 on it, and then you don't have to worry about dividing by negatives. All right, let me see my substitution people. All right, my substitution people, x equals 4 minus y. That means this x in my top equation, I can replace it with 4 minus y. Please be careful, though, because it was getting doubled. So now I would have 8 minus 2y plus 3y equals 9. That's going to give me 5y. Oh, I'm sorry, not 5y. 1y. Just making sure you're paying attention. 1y. 1 positive y. So 8 plus y equals 9. Move the 8 over, and what's y equal? I got 1. Did y'all get 1? Okay, then I got to go back and put 1 in somewhere. I think the bottom equation looks easier. I'm going to take this y out and put a 1 in its place. So x equals, instead of 4 minus y, x equals 4 minus 1. So x would equal 3. So my point would be 3 comma 1. Now, even if you are not a calculator person, you're going to need to be, because I'm telling you, you're going to have some unpleasant numbers to deal with in a minute. You're going to have some fraction or decimal answers, and I promise you, you got to embrace the calculator way. It really does make your life easier, and you've got to get good at changing from this form to slope-intercept form anyway. So let's move this guy around. All that happens, 2x moves to the other side, becomes negative 2x. Are you with me? Divide everything by 3, which you could do individually, or you could just do negative 2x plus 9 in parentheses, and then a giant divide by 3. I'm getting y equals negative 2/3 x plus 3. This one, not bad at all. If I move this y over here, it's going to become positive y plus x equals 4. You see what I'm saying? Now move the x to the other side. So now I have y equals negative x plus 4. It doesn't take long to convert into slope-intercept form. I'm going to go back to Zoom 6. Okay, so here, what do we have? Y equals negative 2/3 x plus 3. Down here we have y equals negative x plus 4. Make sure I can see it, because if the calculator can't see it, it won't tell you the intersection. Definitely can see it. Second function, calculate, intersection, first curve, second curve, guess. There we go, 3, 1. 3, 1, just by changing around the forms, which is a skill that you have got to be experts at anyway. Wait, hold up, what now? Okay, you try this one, number 4. And I really want you to try the calculator way. Because first of all, look at this. Is this ready for substitution anyway? No. Now we could make it ready for substitution. If you're one of those people who likes to do it both ways, you're like, I'm going to do it by hand, I'm going to do it by calculator, and I'm going to make sure I get the right answer, which I think that's great. You have to make a choice though. If you've got to get an x or a y by itself, look for an x or a y that just has a 1 or a negative 1 in front of it. Those are the easy ones to get by itself. So what would the easiest thing to do if you were just dying to do this by substitution? Yeah, do you see the bottom equation? Look at the x. What's in front of that x? Just a 1, an invisible positive 1. So if I was dying to do substitution, then I would just change this to x equals 2y plus 7. And now I'm ready for substitution. However, I really want to encourage you to try this calculator. All right. Go. How do you do what? Okay, if you're going to do it in the calculator, then it has to be in slope-intercept form. That's the only way that we can enter it into the calculator, y equals mx plus b. Or at least solve for y. It doesn't even have to look exactly like mx plus b, but y definitely has to be by itself. Somehow, some way. So you have to move stuff around until y is by itself. You put it in the calculator. You calculate where they intersect. That's how you do it in the calculator. Who can tell me the equation, the top equation? Once you manipulated and moved stuff around, what did you get for the top equation? Because if you mess up here, guys, it's not going to work. Go ahead. Carlos, yes. For this, you got y equals x plus 2. All right, let's see. Okay, first of all, couple of choices here. Honestly, when I see a negative 3y, I just prefer to move it so I don't have to deal with negative y's. So what I would have done first here is move the negative 3y to the other side. Then I would have had 3y plus 3x equals negative 6. Now I can move the 3x over. 3y equals negative 3x minus 6. Now I'm going to divide every single thing by 3, and I'm getting y equals negative x minus 2. I had different signs than you, Carlos. You got to be very, very careful, because if you mess up there, then nothing is going to be correct. This is why it's not a bad idea to do it 2 ways. Okay, who can tell me the bottom equation once we move stuff around? Yes, Dylan. Y equals what? Plus 7 over 2. Alright, let's see. I'm going to move the x over, so I have negative 2y equals negative x plus 7. I'm going to divide everything by negative 2. Now you got to be really, really, really careful. I get y, I get 1y, but what is this? It's positive 1/2 x, or positive x over 2. Plus 7 over 2. So you have got to be so careful with your signs to make this method work. You could put 1/2 x, yes. 1/2 x or x divided by 2, same thing. Alright. If you're making mistakes with signs, then this is what I would suggest you do. Like Dylan right here, you could have done this. Negative x plus 7, you just could have wrapped it in parentheses and then divided the whole thing by negative 2. And then the calculator would have known to turn that positive, and it would have known. Wait. Oh, this should be a negative 7 over 2, shouldn't it? Right? Negative 7 over 2. I forgot that negative sign. I had it wrong. Alright, so let's try this. Y equals negative x minus 2. Then the other one, y equals 1/2 x, or x over 2 minus 7 over 2. Does not matter the order. Now look right here, please. Everybody focus up here for a second, because I had a kid last period who put a negative symbol in between here. When you're separating two terms with a negative symbol, guess what it does to those terms? It multiplies them. You cannot use a negative sign in between two terms. Alright, now we're going to calculate where they intersect, if we can see it. And we can see it. First curve, second curve, guess. I'm getting 1 comma negative 3. Okay, now please stick with me. I know this is long. But pretend like Mrs. Heim never told you anything about systems of equations. But you had answer choices. And one of your answer choices was positive 1, negative 3. Guess what you could do? Plug it in and make sure it works. Now it has to work on both. Let me put a 1 in for x and a negative 3 in for y. This would give me positive 3. This would give me positive 9 minus 6. Well, is that true? Does 3 equal 9 minus 6? It doesn't? 9 minus 6 is 3, isn't it? Alright, let me put it into this one. I'm going to put a 1 in for x. I'm going to put a negative 3 in for y. This would become 1, and a negative 2 times a negative 3 really becomes a positive 6. Does 1 plus 6 equal 7? So, Chris, do you see that that's the only point that would work on both of those equations? So even if you didn't know how to solve it, there's lots of things you can do on the test by plugging in the answer choices. All right, try this one, please. 2x plus 3y equals 7. 3x minus y equals 5. I would strongly suggest calculator. If you are just bound and determined you're going to be a substitution person, which equation should you move around then? The second one, y. If you're going to do substitution here, look for a letter that just has a 1 or a negative 1. Look at that bottom equation. Do you see how the y has a negative 1? That's going to be the easiest one to try to get by itself if you're dying to do substitution. What does Miss Heim want you to do, though? Calculator. So get busy. I don't want to see silliness. Solve them for y. Put them in your calculator. See where they intersect. On the bottom equation, guys, all you got to do is switch the negative y and the 5. Switch the sides they're on, and it makes it so easy to solve that one for y. Move the negative y to the other side, it becomes positive y. Move the 5 back to the side with the 3x, it becomes negative 5. But please be careful here. No. Aaliyah, tell me what you got for... Who is Aaliyah? Malaysia. Tell me what you got for the first equation. You got y equals what? Plus 7 over 3. Great job. You got to move the 2x over, it becomes negative. You divide everything by 3, you get negative 2/3 x plus 7/3. Alright. The Mia of Malaysia, what'd you get for the bottom one? Oh, come on now. Seriously, look up here, it's so easy. Move this over here, and what does it become? Positive y, right? Move the 5 to the other side and it becomes negative 5. You're just kind of exchanging these places. Anytime you move something across an equal sign, its signs change. So it looks to me like that one would become y equals 3x. Then what? Y equals 3x minus 5. Alright, put those in your calculator. See where they intersect. Are they, before I even put them in, are they going to intersect? They have to. How do I know they have to? Because they don't have the same slope. If they had the same slope, they wouldn't intersect. Y equals negative 2/3 x plus 7/3. I did? Alright, and then the other one is y equals, what, 3x minus 5? If I can't see it in the screen, I gotta zoom out, but I think I can see this one. Yep, there it is. Second function, calculate, intersection, first curve, second curve, guess. I'm getting 2, 1. Is that what y'all got? Dylan, did you get that? This is important stuff here. Alright, just a few more examples because I want to show you when you have to zoom out. I want to show you when you get not nice numbers, meaning fractions or decimals. Try this one. X minus y, this is number 6, right? X minus y equals 16. X plus y equals 74. Shh, let's go, let's go. ladies. Okay, again, on the top equation, I would just exchange the y and the 16. If some of you are having trouble with negatives, move the y to the other side, and then move the 16 back to be with the x. Who can tell me what that top equation becomes? Yes, y equals x minus 16. What about the bottom one? Y equals negative x plus 74. Absolutely. Now, let's see what happens. Wow, very good. Y equals x minus 16. Y equals negative x plus 74. Okay, now, when I graph this, I couldn't see it. When you can't see it, folks, I need your attention. When you can't see it, what do? Zoom out. You have to press enter. Second function, calculate. What did you do? Oh, and good point, guys. Look what happened here. I zoomed out, and I still couldn't see it. So what do I have to do? Zoom out again until you can see it. Now, it distorts the picture. It's not a very good picture, but as long as I can see it, it'll tell me 4529. Are we good with that? Okay, 2 more, and then we're going to grade homework. Try this one, please. 3x plus y equals 1. 7x minus y equals 1. Focus, folks, because I still have a lot to do with homework. We have a lot of assignments. Shh. I know. We're going to try to get it at least. All right, ladies. Let's focus. What? February. Okay, can I ask you a question? Can we stop talking about random events and do this math problem? Please. Or you know what would even be better? If I was born on February 29th, I would like to celebrate it in February and March. How's that? Both. All right, get busy. I want you to see what happens here. The reason why I want to do this one, folks, is it's not nice whole numbers. Chris, are you doing this? Do this problem. It's not optional. All right, what's the top equation become? Y equals what? Negative 3x plus 1. What's the bottom one? Y equals 7x minus 1. You have to solve for y correctly. I'm going to go back to Zoom 6, so I'm back to my normal screen. Please be careful when you are changing your lines around. Y equals negative 3x plus 1. And y equals 7x minus 1. And I'm going to calculate where they intersect. This is why calculator is easier to me on ones like this, because look what the answers were. 0.2 and 0.4. It's not going to be that fun to try to work with decimals. What's another way they might have that written? Fractions. You all know what that would be? Well, it would be 2. It would be 2/10, which is a fifth, and 4/10, which is 2/5. All right. Last one, and then we're going to grade homework. Please focus. Y equals 2x plus 3. 6x minus 3y equals 9. Hush, please. Get busy, get busy, get busy. Ladies. All right, have we noticed something about these? Yeah, they're not the same thing, are they? They're parallel. What does that mean? So what would you tell